Vectorscopes are very useful tools if you know what they are for and how to read them. I usually start my setup with the vectorscope. It is used to monitor chrominance or the strength of color. The screen is split into 6 sections. Each section represents a color, both primary and mixed. There is a target in each section with the color that section represents. The level of chrominance is measured from the center to the outside. The center target represents 0 color. The further the signal is from the center, the stronger the chrominance. When color bars are generated, each bar should sit in its target. First, I would check the black balance. Put the lens cap on so the screen goes black. The vectorscope analyzes color. As there is none present, the dot should be small and in the center of the target. If it is not, it means you need to balance the blacks. If your black is offset, your shadow areas will have a tint. You can tell what color tint you will have depending on which section the dot is veering to. This will also result in more visible grain. It's an easy fix on the shoot. If the camera does not have a black balance button, then a reboot or a restart will usually do it. To check white balance, hold up a white reference card. Ensure it covers the entire screen. If it is off center, it means your color temperature is set to a different degrees Kelvin than the light you are shooting with. This is not a technical problem, it can be a creative decision. I do sometimes shoot deliberately with the wrong color temperature, depending on the look I'm after. This process will tell you exactly what the color is, so you can make informed, creative decisions and keep control of your image. This is the only accurate way to read your color. Never trust the color you see on the broadcast or camera monitors. They lie. Not because they are set up incorrectly, although they often are, but because external elements change the way we see color. The temperature and intensity of the light around us, for instance, can radically alter your perception of color. The blue square in the center is constant. It is not changing brightness or color. Only the border around it is changing. The vectorscope tells you precisely what color is on the sensor, unaffected by any external factors. Vectorscopes come in very useful when shooting chroma keys. You can see at a glance exactly where your color screen is in relation to other colors. A green screen, for instance, should be here. The closer the chroma color to the edge of another section, the more colors you will have to avoid in costume and props. Use the vectorscope to check these colors. Often, aqua is mistaken for blue in costume design. To the eye, in daylight or fluorescent light, it tends to look blue, but captured in tungsten, it tends to be closer to green. This is much too close to the green section of the scope and the chroma color to be an easy key. Keeping an eye on the vectorscope when shooting chromas has saved me many hours and possibly days in post trying to pull keys from similar color costumes. This is how the vector would look with every color in the frame presented on the scope. We can see at a glance that there are 3 colors present in the shot. This line in the green section of the scope is the chroma green screen in the background. The reason this line is stronger than the others is because the green is quite saturated. The reason it is narrow is because the shade and color is constant throughout the frame. If there were many shades and hues, the line would be much thicker. But it is a chroma, so you want it to be one shade and one chrominance. This line in the blue section of the scope is the color of the dress. The line is short because the blue is pale with muted chroma. It is wide because there are many different shades and strengths of blue covering a wider color field. But we can see they are all in the blue section, so the green will separate well for a clean chroma key. The third color is magenta. This is the chrominance of the skin tone. The line is weak and closest to the center. This is because it's the closest to white of the 3 colors. It is dispersed over a wide field because there are so many shades of skin tone, but all sit in the white and magenta section, so they are very safe for the chroma green. The vectorscope I am demonstrating to you now is a datascope fashioned on the classic cathode ray format. Most scopes still stick to this look, but they don't have to, as long as the color sections are in the same place. It takes a little time and practice to fine-tune your skills on reading the vectorscope, but once you have mastered it, you can see everything you need to know about the color of your shots with one glance. And the more you know about your shot, the more you can control it.